were discussing about linear elements. Which elements are linear? Obviously, resistance is a linear element, B is equal to R I, and when input voltage is 0, current will be 0 always, no problem. But in case of an inductor, it is not going to be. If current is your response, you are applying some voltage V, then we have seen I is equal to 1 by L V dt. If your game starts at t equal to 0, it will be 0 to t at any time. And only thing that inductor will be linear, that is what I showed in my last class, provided there is no I 0 minus must be 0, then only inductor will behave like an linear element, that is superposition will hold good. If you apply V 1 voltage, if the current is I 1, then if you apply V 2 voltage, current will be I 2, then I am saying if you apply V 1 plus V 2, then current will be I 1 plus I 2. It is a very powerful tool in circuit analysis. That is why linearity is always preferred. Now, the question is there will be situations, as we have seen, inductor current, initial current may not be 0. You have connected it to some other circuit, inductor got some initial current I 0 minus, then you are connecting it to another circuit and current through the inductor will start from I 0 minus. Therefore, at that time superposition theorem application will become definitely a troublesome thing, and superposition is such a powerful tool. Now, to what happens when inductor has finite initial current. That is, there is some definite I 0 minus present, non-zero, I 0 minus is non-zero. And by this time you must have understood what do I mean by this. This inductor was connected in some other circuit, at some time you are connecting this inductor to some other circuit, and subsequently you want to know what will be the current, then current variation in the inductor should start from I 0 minus. And I am telling, if the inductor has got initial current, it cannot be treated as a superposition, it cannot be treated as a linear element, hence superposition cannot be applied, things like that I am telling. Is there a way out to avoid, because that will be the situation in most of the cases. So, what happens when inductor has finite initial current I 0 minus? Then the current at any time t in an inductor, we have seen it will be equal to I 0 minus plus 1 by L 0 to infinity B dt. This several times I wrote like this, where B is a reasonable voltage, not an impulse. This is the situation. So, initial current plus this extra current in the inductor. Okay. And this expression is the current through an inductor which has got no initial current. Therefore, at this point you please be with me and try to understand what I am telling. A crucial point, an inductor and its current at any time t is I t, and it has got some initial current I 0 minus. and these 2 points are suppose A and B, terminal of this inductor with initial current. Now, from this equation, I can say this inductor L without no initial current, and this is IT, and here is a current source I 0 minus. And these 2 points are your A and B. Got the point? That is an inductor with an initial current I 0 minus, current at any time t. You see I 0 minus plus this term, but this term is the current in an inductor without any initial current. Therefore, what we are doing is this inductor, this red colored coil L having same value L, this part, this inductor has no initial current. Therefore, an inductor with initial current I 0 minus can be thought of as the same inductance L without any initial current, but across it another source is connected whose value is I 0 minus. You see this I t is indeed I 0 minus plus this term 0 to infinity 1 by L, 0 to t 1 by L v dt. So, that is why it is connected in parallel. Got the point? This is a crucial point. An inductor, if it has got no initial current, fine, this inductor will remain inductor A B, but an inductor having an initial current I 0 minus, you can think that we think without any mistake, you can replace this arrangement with an inductor same value without no initial current in it, and that initial current you treat it as a current source across it, and everything will be fine. Now, why people do like that? People use this concept, replacing a charged inductor in this fashion, simply because that an inductor, if you treat it with I 0 minus, show it in the circuit, this L is not a linear element, and you will struggle while applying the superposition theorem. In fact, you will not be able to apply superposition theorem. Therefore, translate these to an inductor having no initial current, therefore, superposition theorem can be applied to this element, and this is just another source. In superposition theorem, when many sources are present, consider one source at a time and find out the current in the circuit and get the solution. We will take up several problems, but this concept please try to understand, appreciate what is done from here to there. Therefore, in a circuit when such an inductor is present with initial current, I will simply say, for example, let me draw a circuit so that everything is in place. Suppose you have a circuit like this. I say it is a 10 volt battery, here is a plus minus 10 volt source, and I say that here is some resistance 4 ohm, and I say that I will connect an inductor L which is suppose 2 Henry, but it has got some initial current. I will indicate it by this I 0 minus, got some other circuit and connect it to this circuit at t equal to 0. Okay. I can write down the differential equation and initial current is 0, that is one way of solving. Now, I am telling from the point of view of superposition theorem I want to do. There are now, so this circuit, call this as A and B. You say that circuit for t greater than 0 will be like this 4 ohm, your battery is there 10 volt, and I will draw it with a red color to indicate that it is an inductor 2 Henry with no initial current, and this initial current is here. Show it by a, say suppose I 0 minus ampere is 1 ampere, say 3 ampere. So, I will connect it like this. So, in this circuit there are two sources, one is a voltage source, current source, and both these elements are linear, this 2 Henry and 4 Henry. Therefore, I will consider one source at a time and find out the currents in the circuit. Got the point? So, this example you try first, then I will solve it. But only thing is, we are looking for current in this inductor. After you find current in this inductor 2 Henry, which has got no initial current, do not forget to add this plus 3, because actual circuit, this inductor current is this current in the 4 ohm resistance, and that current is here. You should be careful, that is all. Otherwise, you can apply superposition theorem as well. Is not it very interesting? That is, okay, one way of handling this situation I know, I will write down the differential equation, solve it, initial condition I 0 minus equal to 3 ampere, one way of solving. But keeping in mind principle of superposition will be so often used in later stage of this course, then we ask ourselves, we are investigating whether an inductor really is a linear element or not, then only you can apply superposition theorem. Then we discovered that okay, inductor indeed will be linear provided there is no initial current in it, because principle of homogeneity must be satisfied. If applied voltage is 0, current must be 0. So, I 0 minus equal to 0, then there is no problem, fine. But as we have seen earlier, an inductor is connected to this circuit for some time, then it is switched over to another circuit, then building up of current in the inductor when it is connected to this new circuit will start from this I 0 minus, current is continuous in an inductor, and this will spoil the game so far as principle of superposition is considered. What is the way out? Way out is this equation. This equation tells you so many things. Okay, I t is equal to I 0 minus 1 by this one. in an inductor with initial current which is non-zero. Suppose AB is the terminal of the inductor, then what I am telling, this is the actual thing, you can treat it as an inductor, same value L without any initial current, and in parallel there is a current source I 0 minus. But in your actual circuit the inductor current is I t. So, this current, in this circuit there will be some current when you solve it. This current is not the current you are looking for. Do not forget to add this current with I 0 minus to get it. I hope you have got the point. So, this is the thing. So, an inductor with initial current can be modeled between two terminals A and B as the inductor without any initial current, and across it there is a current source. Okay? I hope you have understood. Similar is the case with capacitor. Is capacitor a linear element? Okay. This is your C, and here you are connecting some say current source I t, and we know that voltage across the plate of the capacitor V t is the output, B is output. This current which you are injecting feeding to the capacitor plate is the input. Suppose we think in that way, this is my input. So, voltage across the plate of the capacitor we have seen it is equal to minus infinity at any time t is equal to I d t, is not. By the by, remember that to build up voltage across the plate of the capacitor you have to spend coulomb, ampere second. Recall that in inductor to establish a current we had to spend volt second. Similarly, to build up voltage across the plate of the capacitor you have to spend ampere second. Ampere into second is nothing but coulomb, that is you are dumping, it has got a physical significance. Similarly, volt second can be shown to be equal to the flux linkage, those things we will see, but I d t is the one you have to spend to establish voltage across the capacitor plate. Anyway, this is the thing. Now, this one is equal to 1 over C into minus infinity to 0 minus I d t, and if I is reasonable, this will be 0 minus or 0 plus, whatever you write, it does not matter, t I d t. These are the two parts, I not a delta impulse, not an impulse. For this only this is valid, not an impulse signal. Forget about this. So, general function psi t. So, this will be the thing. Now, this thing voltage across the plate of the capacitor at any time t, this quantity is your V 0 minus. At t equal to 0 you are doing some switching, and this one is voltage at any time t is this current, this one, and then 1 by C I d t 0 to t. Now, what is the what we demand for this element to be linear? What is the input here I t? When current is 0, no current is applied, I will demand there should be no output, 0 input, 0 output. This is the first thing, 0 input must cause 0 output, 0 ampere input must cause 0 output. This is the condition of homogeneity for superposition theorem. If this is not true, then it is not going to behave like a linear element. That is what I am trying to tell. Okay. But we know that a capacitor, if you charge it from some other circuit and leave it like this with some initial voltage V naught, what is the current now applied to the capacitor? 0, but it will be able to retain this voltage. It has been charged from some circuit and disconnected. For example, R, this capacitor like that, here is a voltage, you charge it, then after it is fully charged, open it, this capacitor, I mean in ideal condition it will retain this voltage. If this voltage is E, it will have charge to this voltage and it will retain this voltage forever. I mean, which is theoretically not possible. Through the atmosphere there will be leakage, capacitor will slowly discharge, that is one thing, but in ideal conditions it will retain that voltage. Similarly, a capacitor, now no current is injected to it and it has got V naught, that means V 01, let us see, let V 01 initial voltage across the plate of the capacitor is 0. Is it then linear? Let us see. I will give I 1 current and see what is the voltage V 1. So, I will write V 1 t with V 01 is equal to 0 will be simply 1 over C 0 to t I 1 dt. Fine. Input I 1, voltage output V 1, and they are related by this. Then what I will do? I will give another input I 2 with still maintaining V 0 minus equal to 0, initial voltage across the capacitor is 0, and I note down what is the voltage output. So, V 2 t will be equal to 1 over C 0 to t I 2 dt. This will be the thing, I 1 I 2 at the input. Is not that? This will be the thing. Suppose now you excite the capacitor with a current source which is I 1 plus I 2, and suppose it gives rise to a voltage V 3. I am not sure whether it will be V 1 plus V 2. Suppose it gives rise to this V 3. When the input is I 1 plus I 2, what will be the voltage developed across the plates of the capacitor? Then that I will write V 3 t is equal to 1 over C 0 to t at any time t, and this will be I 1 plus I 2 dt. And this can be broken up into these two parts, 1 by C 0 to t I 1 dt plus 1 over C 0 to t I 2 dt, is not. But this one is nothing but V 1 and this is nothing but V 2. Therefore, a capacitor with V 0 minus equal to 0 must behave like a linear element, and superposition is holding good, nothing is better than that. However, if there is V 0 minus 1, you can easily show superposition theorem will not hold good, is not. Suppose although I have not done in case of inductor, suppose V 0 minus is equal to 2 volt. Then let me use separate color. Then I will say when you apply V 1, what will be the output voltage? This 2 volt plus 1 over C 0 to t I 1 dt. You apply I 1, get this V 1. Is not. Suppose I say V 0 minus 1 is not 0, it is 2 volt, and then you are applying V 1 voltage 2 plus 1 by C and so on. Similarly, when you apply separately V 2 voltage, what will be the output with the same initial voltage 2 volt? It will be 2 plus 1 over C 0 to t I dt, I 2 dt, is not? What will be the response of the circuit, that is V 1 plus V 2. If you add these two equations, it becomes then 4 plus 1 over C 0 to t I 1 plus I 2 dt. If you just add these two equations, I have not applied separately V 1 plus V 2. From these two equations, I am telling, oh, this is going to be this. Now, indeed, when you apply V 1 plus V 2 to this circuit, then the voltage, when you apply V 1 plus V 2, let the voltage in the circuit be V 3. Oh, sorry, when you apply I 1 plus I 2, are you following me? I 1 plus I 2 you apply. I do not know, I am not assuming anything, I am telling that okay, let the output voltage be V 3. Then V 3 should be equal to, with same initial condition, 2 plus 1 over C I 1 plus I 2 dt. This will be the thing 0 to t, and which is not same as V 1 plus V 2, it is 4. So, this term will spoil the linearity property of a capacitor if it has got a non-zero initial voltage. Got the point? Therefore, what is the way out? As I am telling you, principle of superposition is a very powerful tool I would like to have in analyzing circuits involving R, L, C. R is a linear element. Inductor with no initial current is a linear element. Capacitor also will behave like a linear element without any initial voltage, fine. But the fact remains that there may be situations when this capacitor and inductor will have their initial currents, voltages and currents. In that case, is there a way out? I will exploit the principle of superposition while analyzing the circuit. I would like to do that, and at the same time I know that okay, initial conditions, then it is not linear, looks like that. In case of inductor, we solved that problem. We told that okay, if an inductor has got an initial current I 0 minus L, and this is the current at any time t across these terminals A and B, this is, you treat it as an inductor without any initial current, but do not forget to connect a current source. So, another source will be introduced into this circuit. So, superposition you apply, this inductor no current. Therefore, in case of capacitor, whether similar things can be done? Yes, it can be done, because of the fact, look at a capacitor. A capacitor C, and let it has got an initial voltage V naught with this polarity, and let this point be A and B. So, this C has initial voltage and voltage across the plate of the capacitor at any time t will be V naught plus 0 to t I dt by C, q by C. This is the equation, and this is the voltage applied across the capacitor V t. So, this V t is a constant number, this is constant, a number constant, and I soon discovered that okay, this V t is nothing but a constant voltage V naught. Therefore, between A and B there is I can consider as if there is a battery present V naught and plus a capacitor C, which has got no initial voltage. This C has no initial voltage. Then it is very nice. So, only thing you have to alter the circuit, bring in another source. Okay, in the circuit there will be sources present, okay, another source comes, but to solve the circuit perhaps I will apply superposition, then for V naught also I will solve the circuit. But only thing to be remembered, this voltage which has got no uncharged voltage is not this V t. Ultimately, in the circuit V A B is the terminal of the capacitor. So, while calculating the voltage across the capacitor, you solve for this voltage. Then do not forget to add this V naught to get the actual capacitor voltage. So, this C is our thought process told me that okay, a charged capacitor can be thought of a capacitor. Why in series? Because voltage sum of two voltages, that is why it is in series. In case of inductor, the current was sum of two currents, that is why it was parallel. I hope you have got the idea, and we will use this substitution, that is a charged capacitor can be substituted by an uncharged capacitor with the V naught. What is the motive for doing that? Because a uncharged capacitor will behave like a linear element, similarly an uncharged inductor will behave. So, to summarize this, so this is the thing for capacitor and for an inductor L with initial current I 0 minus and these two terminals are suppose C D. This is equivalent to an inductor with no initial current and in parallel. This initial current is shown to be as a source and you can solve. This is your A B. Mind you, this current is this current, not A B, C D. I hope you have got the point. Anyway, we will tell more about these things when we will be trying to solve circuits with initial conditions. One way of solving this, forget about this, you do not know how to change this to this or that to that. Write down differential equation, apply boundary condition, get the solution. It has nothing to do with this transformation. But now we will look ahead and we will try to apply several network theorems. Formally, I have not told you anything about network theorems like superposition theorem, but this is the time I slowly start telling about those things. I hope you have understood this point. This lecture is very important, go through it. Thank you.